Hello everybody, this is it, the review sheet. I can prepare for my transformations test by practicing. We're going to go over one of each type of question that's going to be in your test. Let's go. Whenever it asks under which type of transformation will the triangles not be congruent, all rigid motions produce a congruent figure. They all produce a congruent figure except for a dilation. So if it ever says which does not produce a congruent figure, the answer is always a dilation. Reflection, translation, rotation are rigid motions. A rigid motion preserves size and angle measure, producing a congruent figure. A dilation does not. You need to know how to do all the different types of transformations. Let's start with a translation. We're going to start by plotting the points. I've got L2 negative 3. I've got M5 1. I've got N7 3. I know it looks a little weird, but whatever. And it wants me to translate it 2 left and 4 up. So I take each point and I count 2 left, 4 up. 2 left, 1, 2, 3, 4 up. That's N prime. M prime, 2 left, 1, 2, 3, 4 up. That's M prime. 2 left, 1, 2, 3, 4 up. That's L prime. Connect them. On your test, it'll be a more regular looking triangle, and that's it. Does it ask you to state the coordinates? No. If it did, then state them. Translation, you just count on the graph. Reflection through a point. It wants me to reflect this through the point negative 2 comma 3. So I am going to plot the point negative 2 comma 3. And I am going to reflect through that point. So to do any reflection, whether it's a point reflection or a line reflection, you count to what you're reflecting over. If it's a point, you're counting in 2 directions. So for B, I'll start at B. It's left 1, 2, 3, 4, up 1, 2. So left 1, 2, 3, 4, up 1, 2. That's B prime. A is left 1, 2, 3, 4, 5, 6, down 2. Left 1, 2, 3, 4, 5, 6, down 2. C is left 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's a little off the graph. You'll deal with it. Connect them. Oh, no, that's not right. Yes, it is. And that's it. Point reflection, count to the point of reflection, and count the same thing all the way through. All right, we've got number 7. A is 3 comma 1. We've got B is 0 comma 4. We've got C is negative 5, 3. And it wants me to reflect over y equals negative 1. Well, you need to know what y equals negative 1 is. Yancey has X-ray vision. Y equals a number is a horizontal line. So I'm going to make a horizontal line at negative 1. That is y equals negative 1. So now I'm going to count to the line of reflection. Since it's a line, I'm only counting in one direction. For C, I'm going down 1, 2, 3, 4. 1, 2, 3, 4. There's C prime. A is down 1, 2. 1, 2 for A prime. And B is down 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Connect them. It should look the same. It should be the same size. It's just reflected over that line. Looks good to me. Again, if it says to state the coordinates, state the coordinates. If not, then just make sure you label. Number 9, triangle ABC prime is the image of triangle ABC after a translation. Are they congruent? As long as a reflection, a rotation, or a translation happened, or any combination of those, the answer is always yes. A translation is a rigid motion, and a rigid motion preserves size and angle measure, producing a congruent figure. Whenever a reflection, a rotation, or a translation happens, I don't care what the translation is, what the rotation is, the degree, the center, if a reflection, a rotation, or a translation occurred, they are congruent because they're rigid motions, and a rigid motion preserves size and angle measure, producing a congruent figure. Number 11, after a counterclockwise rotation, the triangle maps onto the other triangle. Again, same concept we just talked about. Since a rotation happened, I know that the triangles are congruent. Now, it's hard to see what corresponds to what here, so I'm going to cross those out and draw my own pictures. I've got A, B, C. I've got R, S, T. If I label A, B, C as left, top, right, then I need to label R, S, T as left, top, right. Now that I did that, it becomes a very easy question. I'm going to go through each choice and I'm going to see what corresponds. A and R. Do A and R correspond? Yes. That one looks good. I'm going to go through the rest of my choices. A and S. Nope. A is the left. S is the top. So that one's out. CB and TR. CB and TR. No. CB is the right. TR is the bottom. CA and TS, bottom, right, nope. The answer is choice 1. If you don't draw your triangle separately, if you don't do this, it is very hard to get it right. Make your life easy, draw the triangle separately. So you'll have one of those in your test. Identifying sequences of rigid motions, both on and off the grid, you're responsible for. I'm sorry, not both on and off the grid, both multiple choice and open response. First step, check for orientation. If at this point you still don't know you're supposed to check for orientation, that's the problem. That stinks. GIA, JET. GIA is going counterclockwise. JET is going clockwise. The orientation is different. The orientation is different. That means there must be a single line reflection. A double line reflection keeps the orientation. Point reflection is not a line reflection. A point reflection does not change orientation. It must be a single line reflection. So I'm going to read through the choices and see which one has a single line reflection. Point reflection, that's not a line reflection. Translation, there's no single line reflection, that one's out. Reflection over the y-axis, that's a single reflection. Translation, yes, that one is a single reflection, so it could be that one. A rotation and a translation, that's not a single reflection. A reflection over x equals 1, that's a line reflection. A reflection over the x-axis, that's a double line reflection. No, it must be a single line reflection. That one's out. The only one that's left is choice 2. If you were left with 2 choices, then you would have to go through one of those choices and see if it works. Which brings us to the open response version of this. Again, either way, we start by checking for orientation. A, B, C, D, E, F. ABC is going counterclockwise. DEF is going counterclockwise. The orientation is the same. For the purposes of the open response, it's going to either be a reflection in a translation or rotation in a translation. No double reflections when we are on the grid. So the orientation is the same. Therefore, it's going to be a rotation followed by a translation. Now, we need to be more specific than just that. So we need to use geometric common sense as far as how many degrees and which direction. So because this flat piece is horizontal, and the same flat piece here is also horizontal, it can't be 90, because 90 makes a horizontal into a vertical. If it stayed horizontal, it must be 180. And when you're doing 180, it doesn't matter which direction you go, whether it be clockwise or counterclockwise, but you still have to specify when you describe your transformations. So I am rotating. Here's the rotation. 180 degrees. I'll go clockwise. Centered at. You need a center of rotation, and we always want to use a point that's on the triangle. That makes it a lot easier. So I'm going to choose point A. Centered at point A. So then you could draw a rough sketch. You don't have to. I know that A is going to have to map onto D. So how do I get from A to D? Right 1, 2, 3, 4, 5, 6, down 2. So that's right 6, down 2. Followed by a translation, right 6, and down 2. If you chose B or C as your center of dilation, you would have a different translation. So there's more than one correct way to do these. As long as it works, that's all that matters. So check for orientation. Since the orientation was the same, it's got to be a rotation followed by a translation. 180, just based on geometric common sense, centered at A, and then I translated the rest of the way. You'll have one of those in your test. Number 17, check for orientation. Oops. Deer and Deer prime, D-E-A-R, that is going counterclockwise. D-E-A-R, that is going clockwise. The orientation is different. If the orientation is different, it must be a line reflection followed by a translation. So now we've got to use a little bit of geometric common sense as far as which axis I'm going to reflect over. Being how DE is on the bottom, it needs to stay in the bottom. Therefore, I would need to reflect it over the y-axis, because over the x, it would flip upside down. So I am going to reflect over the y-axis. Now I'm going to do the reflection. So R is going 1, 2, 3 left, 1, 2, 3 left. That's R prime. D stays where it is. It's called invariant. 1, 2, 3, 4, 5 left. 1, 2, 3, 4, 5 left for E prime. And A, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. A prime. Now, how do I get that onto the other one? So let's pick any point. I'm going to pick E. How do I get from E to E prime? I'm going 1, 2. 1, 2, 3, 4, 5, 6, 7. I'm going right 2, down 7. So I go back to my sentence. Followed by a translation. Right 2 and down 7. That's it. All right, check for orientation. Whenever you're identifying a rigid motion or transformation or sequence, if it's different, it must be a single line reflection. If it's the same, if it's open response, it's going to be a rotation. And if it's multiple choice, it could be a double reflection, or it could be a rotation or a translation. All right, we're getting close here. Number 19, to map a shape onto itself. The rule is, or the rules are, Line of reflection equals line of symmetry. Center rotation equals center of shape. Those are your two rules to map a shape onto itself. For reflection, it must be the line of reflection must be a line of symmetry. And for rotation, the center of rotation must be the center of the shape. Actually, it's fine. Let's actually do number 20 instead. That's a mix of reflections and rotations. So let's just bring this with us. So, the first choice is a rotation. For a rotation, the center of rotation must be at the center of the shape. Is the origin the center of the shape? No. So that will not map it onto itself. Let's just, while we're talking about rotations, let's take a look at choice number 3. A rotation of 90 centered at -3, -4. Is that the center of the shape? Yes. Would 90 map it onto itself? With a circle, any degree measure will map it onto itself? That one looks good. Let's take a look at choices 2 and 4, the reflections. X equals -3. Well, again, Yancey has X-ray vision. X equals a vertical line at -3. Line of reflection equals line of symmetry. Is that a line of symmetry? Yes. Y equals -4. Horizontal line at -4. Is that a line of symmetry? Yes. Which of them does not map the shape onto itself? Choice 1. Line of reflection equals line of symmetry. Center rotation equals center of shape. Which brings us to the next part of the song. Min rotation is 360 over n. For the minimum rotation to map a regular polygon onto itself, your first step is 360 over n. And then you also need to understand that any multiple of that will also map it onto itself. So I start with the minimum rotation. For an octagon, we do 360 divided by 8. That is 45. So a degree measure of 45 will map it onto itself. I don't see that there. Any multiple of that will also map it onto itself. So now I need to go through the choices and see which one is a multiple of 45. Well, it obviously can't be 10 because it's smaller than 45. So is 150 a multiple of 45? Well, 150 divided by 45? No. 225. Is 45 a multiple of 225? Yes. So that one looks good. I'm going to go through all 4 choices, though, to be sure. 252 divided by 45. Nope. Choice 3 is your answer. The minimum rotation is 360 over n. Any multiple of that will also map it onto itself. 225 is 45 times 5. Every exam, every test will have at least one old topic on it. So this is definitely the most important thing from the first unit. Our complex triangle problems. Look for linear pairs. Look for angles of a triangle. If you have an isosceles triangle, you mark the sides. You mark the angles opposite them. Equilateral, 60, 60, 60. Angle bisector cuts an angle in half. And parallel, you follow the transversal. So it says that ADB is equilateral. So if ADB is equilateral, I know the angles of ADB are 60, 60, and 60. It's also telling me that DB is congruent to BC. So I mark the sides, and I mark the angles opposite them. Now I look for linear pairs and angles of a triangle. There's my linear pair. 180 minus 60 is 120. I look for a triangle. I see a triangle. I have 120, and then the other 2 angles must be the same. So I subtract 180 and 120 to get 60. Since the other 2 angles are the same, I cut it in half to get 30 and 30. The question is asking for the measure of angle C. Angle C equals 30 degrees. And that's it. There's 24 questions on your review sheet, so there'll be 12 questions on your test. There's 2 of each type. You know exactly what you're responsible for knowing. You have this video, you have keys, you have a video for every single lesson for all 12 of these things, a full lesson. Put the time in, practice, make sure you know how to do all 12 types of questions. If you do, you should do great. And if you don't, then you will not. Practice, 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 or don't. Make the right choice. See ya. See ya.